This is example 1 of the Systems of Linear Inequalities lab. We have the following problem. We want to find the max and min of the objective function s subject to the constraints below. So this is our objective function. S is equal to 2x plus 10y, and it's subject to these constraints. Y is greater than 10, x plus y is smaller or equal to 50, and negative x plus y is less than or equal to 50. 2x plus y is greater than or equal to negative 10. So we want to find what the max and min of s is on these constraints. So our first step is to actually find where all these constraints intersect with one another and graph them. So if we graph these constraints, we're actually going to write it as y is equal to 10, but then go at greater than. So when we graph these, we'll end up with something like this. So you see that here's y is greater or equal to 10. We have everything above it. Here's x plus y is smaller or equal than 50. We have everything below it. And we have negative x plus y is smaller or equal than 50, so we have everything below it. And we have 2x plus y is greater or equal to than negative 10, so we have everything above it, and that gives everything within this shape. Everything in here is our solution that it's able to be. Each of these are lines, but we crossed them because we only care about the intersection points here. So we know that our objective function s will meet its max or min at one of these intersection points where our constraints intersect. So we're going to write down what each of these intersection points are. So this one is 0, 50 on the graph. This point is 40, 10. This point is negative 10, 10. And this point is negative 20 and 30. So we have all these intersection points. You could also, if you didn't want to graph it, you could also solve these points by finding out where all of these intersect by using substitution or elimination. I'm just skipping that step, but you could do that. So now that we have all our intersection points, we're going to substitute them back into our objective function to figure out which one is our max and our min. So, I'm going to write a big table. So our intersection points are, we have 0, 50, we have negative 20 and 30, we have negative 10, 10, and we have 40, 10. So those are all our intersection points, and we want to put it into the objective function s, where s is equal to 2x plus 10y, and whatever the result of what s is equal to will be either a max or a min or something in between. So now we're going to substitute these points into this objective function. So for this first one, we have s is equal to 2 times 0, substituting x for 0, plus 10 times 50, substituting 50 for y. This gives us, this is equal to 2 times 0 is 0, 10 times 50 is 500. That's pretty good, so we have s is equal to 500 for this first point. For this next point, we have negative 20, 30. So substituting that, we have 2 times negative 20 plus 10 times 30. 2 times negative 20 is negative 40, plus 10 times 30 is 300. So we have 300 minus 40, which is 260. So for this next one, we have s is equal to 2 times negative 10 plus 10 times 10. 2 times negative 10 is negative 20, plus 100 is 80. And for this last one, we have s is equal to 2 times 40 plus 10 times 10. So that's 80 plus 100, which is 180. So you look at each of these numbers that s is equal to. S is equal to 500 at this point, s is equal to 260 at this point, s is equal to 80 at negative 10, 10, and s is equal to 180 at 40, 10. And we look at these and we go, well, 500 is the biggest, so that's our max. And it looks like 80 right here is the min. So our max of S is 500 at the point 0, 50. And our min is this 80 at the point negative 10, 10. And we have successfully found the max and min of our objective function S.